Alrighty, last lesson of the quarter, volume, finding the volume of a sphere. So go ahead, grab your notes, and let's get going. You'll be able to round out your notebooks nicely with volume of a sphere notes. Where's the top of the page? There it is. Okay. Volume, today we're talking spheres. Okay. So first of all, a sphere is hopefully a shape that we are familiar with. Anything ball-shaped, like a tennis ball, a basketball, soccer ball, baseball, those are all sphere-shaped. The Earth is roughly spherical. Of course, it's funny, these pretty much all the shapes that we've talked about so far, like the perfect version of those shapes don't exist in reality. They exist, in theory, which is probably the most important place for them to exist. But if you think about it, nothing's perfect sphere, even though it might look really, really close. And a close enough approximation is what we need. But anyways, that's besides the point. When we draw a sphere, the way that I typically like to do it is draw a circle. And then we'll do like something like this to show that it's got shape, or that it's kind of, three-dimensional here. You can do something like this if you like to show that it's got that third dimension behind as well. Some people also like to do something like that. With drawing spheres, these are at least a little bit harder to mess up than pyramids and stuff like that. I found those much harder. But anyway, that's how I typically draw a sphere. Sometimes I nix that line and just do one like this, but we get the idea. Anyways, so this is a sphere. And spheres will typically have either a radius or a diameter noted on them. So a radius, again, would go from the center to the edge, just like on a regular circle. A diameter would go all the way across the sphere through the center. So if you had a diameter, it might look something like this instead. Or it might look like where the radius is at, just all the way across the circle or all the way across the sphere. Anyways, the volume formula. Volume equals, you're going to see it written two different ways. You can do 4 pi r cubed over 3 or 4/3 pi r cubed. This version is a little bit easier to toss into the calculator sometimes, 4 pi times the radius cubed over 3. But this way also works, and depending on the calculator you're using, might be just as easy to toss into the calculator. Anyways, that's our volume formula. So all we really have to do is plug in the radius. It's a very plug and chug type of problem. Anyways, so let's do a couple of examples, and then we'll probably be good to go. Example 1, here's our sphere. There's the center. And here's our diameter. We'll say the diameter is 10 meters. And we want to find the volume. All right. And we know that volume is 4 pi r cubed divided by 3. And if you're not really into memorizing formulas, this would be a good one to have just written down somewhere in your notes, especially then, so you can reference it. All right, so on this one, we are given the diameter, which is 10. So what would the radius be if the diameter is 10? What would the radius be if the diameter is 10? Any thoughts? So if the diameter the whole way across is 10, remember the radius up here is halfway across. So what would half of that be? 5. There we go. Remember, the diameter is 2 times the radius. The radius is 1/2 of the diameter. So it would be 5. All right. So now that we have the radius, we can plug that into our volume formula and we are good to go. So our volume in this case would be 4 pi times 5 cubed over 3. So then we want to put that into a calculator, and sometimes we have a little bit of difficulty putting something like this into the calculator because we haven't done stuff with cubes very much. So if you're using a regular scientific calculator, let me see if I can get more light on that for us. Maybe. All right. Well, hopefully we can see it okay. If you're using a calculator kind of like this one, you might notice that there is an X with a little box up in the corner, or you might have like a little arrow key that's going up, like an up caret type thing. Those would be what you could use. That'd be like this calculator here. This calculator has that little up arrow. So that's what you use to get an exponent that's not 2. Because a lot of times you have like a square button because you use that a lot. But to get it to a different exponent, you'll use the other key for that. So we're going to go 4 times pi times the radius, which was 5, to the 3rd power, and then divided by 3. We can do the same thing on here. 4 times pi times 5 to the 3rd power divided by 3. It all works the same way. You can also do the whole 4/3 pi r cubed thing if you want. You should get the same answer either way. Our answer in this case, even if we round to the nearest hundredth, it would still be 523.6. And this would be cubic meters. All right. And if you were doing this on Desmos, I'll show that as well really quick. So you can either use the like up caret button on your keyboard if you hit like Shift 6. That will do it. Or you see this one that says a to the b power here. If you click that button, it will put you up into the exponent and you can put it to the 3rd power. So that should also be something that we can do here. So again, if you use that, either the a to the b power, or you can hit Shift 6 and that will get you up into the exponent. All right. So there's that, how we would do it on various calculators. Any questions with that first example? Okay. Then let's do one more, and then I'm going to have you guys try one, and then we'll probably be done. All right, this time we've got our sphere. And we are told that this right here is 7 inches. And we still know volume, 4/3 pi r cubed. So in this case, what's our radius going to be? Are we given the radius or the diameter? And given that, yeah, our radius would be 7. Awesome. Yep, this time we're given the radius. So you could be given the diameter, like in this question, where you'd have to divide it by 2 first, or you could be given the radius straight up and you don't have to do anything to it. We know that r is 7. So then volume, 4/3 times pi times 7 cubed. And we would want to type that into our calculator. So if you're working with just a regular calculator, 4/3 times pi times 7 to the 3rd power. 1436.76 approximately if we're rounding to the nearest hundredth. And that would be cubic inches. Okay. So there's 2 examples now. Kind of covers both situations where you're given the diameter or where you're given the radius. Now you guys get to try one. And here we are told that this measure is 18 feet. Go ahead and find the volume. When you think you've got it, type "got it" in the chat. All right, Caleb's already got it. If you figured out that the diameter is 18 here, so the radius is 9, you're on the right track. Lauren, Kaylee got it. Jade, awesome. So then using our volume formula, we should have 4/3 times pi times 9 cubed. All right. Those of you who think you have it, what did you get? Yep, that's what I got as well. 3,053.63 cubic feet. All right. Any questions from any of these? Any steps we want to go back to? Any numbers we're not sure where they came from? Okay. I guess one other thing that I'll add to this real quick, just curious, if I wanted to find the volume of just half of a sphere, like if I only wanted to find the volume of the top half or the bottom half of this sphere, what could I do at the end? Divide. Yes, Marissa. we would divide by 2. So if I wanted to find the volume of just a half a sphere, you can find the volume of the whole sphere with that radius and then just cut it in half. That's the only other thing you might run across. If you had half a sphere or something like that, you can just take the whole sphere and divide by 2. But that's pretty much everything that we could possibly see with volume of sphere. So with that, let's go ahead and take a look at the homework assignment real quick together. We'll talk about the exit ticket we have today, and then we will get out of here. Okay.